Let's learn ambiguity in significant figures. What does it mean? Ambiguity means confusion. Confusion. This topic suggests confusion. Confusion is created in sense of significant figures while counting the numbers of a result. Suppose a measured result is, let us take one example. Let us take one example, that is a measured length. A measured length is, suppose that x equals to, take any length, 2.800 meter. Okay, this is a measured length. A measured length is x equals to 2.88 meters. Let us see how the confusion happens, how the ambiguity happens, and what is the way to tackle it. This topic, ambiguity in significant figures, is very important in sense of board exam questions. There comes some theoretical questions like, discuss ambiguity in significant figures. This is an important question. Let us understand what this is. A confusion. What confusion happens if we measure length in a measurement? It comes 2.800 meters. Here the double zero, these two are significant, so it has 4 significant figures. Okay, 4 significant figures it has, because we know according to the rule the trailing zeros are significant in a decimal number. Okay, so here if we convert this meter into, let it be kilometer, then x may also be written as 0.002800, this kilometers. Okay, and it has how many significant figures? And this will be invalid according to the rule. This 4 will be the significant, four significant figures. Okay, unit is changing, significant figure remains same. And now the next, if we convert it into, let it be millimeter, then x will be 2800 millimeter. Okay, simply multiply 2.8 meter into 1000. We will get the conversion result into millimeter. Okay, how many significant figures are there in this? 2800. These two trailing zeros will be insignificant, as the rule suggests. The trailing zeros are not significant in a non-decimal number. Okay, so it has 2 significant figures. But the rule tells what? The same result, the same measurement has, in one case 4 significant figures, in one case 4 significant, and in one case it has 2 significant figures only, the same result. This is the ambiguity in significant figures. This is a confusion. Now to tackle this, this question also comes, how to tackle ambiguity in significant figures, how to overcome and ambiguity in significant figures. If this question arises, to remove, then we write, to remove such ambiguities, to remove such ambiguities, what we do to remove such ambiguity? The best way to report in scientific notation. What we do? The best way is to express the results in scientific notation. The best way to remove such ambiguities is what? Express the measured result in scientific notation. Okay, so the ambiguity in significant figures, this is a confusion of what? The number of significant figures in different units is coming different. Okay, and to remove such ambiguities, what we do? We use scientific notation. Okay, scientific notation is what? This is a notation: a into 10 to the power b. Okay, where b is exponent and a is a number between what? 1 to 10. A is a number between 1 to 10. Now let us see how to overcome by using uh, scientific notation. How we overcome this case. Here it should have four significant figures. And then how to overcome this? Let's see. Now let's see. The result was what? X equals to 2800 mm. 2800 mm can also be written as 28.00 into 10 to the power 2 mm. Here we see this part is irrelevant of significant figures. Okay, irrelevant. Okay, irrelevant in case of significant figures. No need to find out the significant figures in exponential form. Okay, this you can write b as exponent or order of magnitude. Okay, and so here it is. Here how many significant figures? 4 significant figures. So now the result is written as, if it is written as x equals to 28.00 into 10 to the power 2 mm, it will have 4 significant figures. Now you can see the ambiguity is removed. Okay, so this is ambiguity in significant figures, and to remove this ambiguity, what we do? We express it in scientific notation, and here is the rule of scientific notation, that is a into 10 to the power b. We use this type of notation. Here b is exponent or order, and a is in number between 1 to 10, and then we expressed this measurement as it had only 2 significant figures. What we have to do? We have to make it in 4, so we made it in 4 significant figures. We can also express these two in scientific notation, and we can make according to our necessity, that how many significant figures we need. Okay, we made it 4. If 1 0 we will omit, it will be 3, but here the necessity is 4, so we will write 00. Okay, thank you.